This video goes over trigonometric functions, stretches, and compressions. We'll change this. This should be 6,4. And we've got two new parameters that we're introducing. We've got a in front, and then we've got k in front of the x. Just like before, if a is greater than 1, the graph of y equals sine x or cos x is stretched vertically. If a is between 0 and 1, it is compressed vertically, and if a is less than 0, the graph is reflected. So the period is not affected. That remains unchanged. Our period is 360 degrees, or 2 pi. Our amplitude is changed. It is now equal to a, the parameter that is in front of the sine or the cos. Our maximum and our minimum value have also changed. Our max is now our axis of the curve plus the amplitude. Our minimum is the axis of the curve minus the amplitude. Our domain is unchanged, still equal to minus infinity to plus infinity, and our range is now, we should be using square brackets here because we can actually get to that value. It's going to be from our minimum value to our maximum value. So for example, y equals 3 cos x. This will be a vertical stretch of 3. So our maximum value would be 3. Our minimum value would be minus 3. Our amplitude is equal to 3. And our range would be from minus 3 to 3. Let's look at a horizontal stretch and compression. So if k is greater than 1, the graph is compressed vertically by a factor of 1 over k. If k is between 0 and 1, the graph is stretched vertically by a factor of 1 over k. If k is less than 0, the graph is reflected in the x-axis. Okay, and it does have an effect on the period this time. So our period is changed, and it's connected by the equation 360 divided by k, or 2 pi divided by k if you are working in radians. T is the parameter that we're going to use to represent the period. Our amplitude is unchanged in a horizontal stretch. Our minimum and our maximum value are also unchanged. And our domain and range are unchanged as well. The only thing that does change is our period. So the value of k is related to the period through the equation that we have written above, 360 divided by k. So for example, if we have y equals sine x, this would be compressed horizontally by a half, and our period would be 360 divided by 2, which means that it takes 180 degrees to complete a full cycle. So our trig graph has been squished together or compressed horizontally. So let's take a look at graphing. Really, these are the same that we did for the trigonometric functions, the translations. We're going to sketch our midline, sketch the max and the minimum lines, use your phase shift. We don't have any phase shifts here. And then we're going to plot the endpoints for the cycle. So 1 point from the starting point, and then at D plus the period. Then we're going to divide the distance between the start and end points in half, and then we'll divide each of those sections in half and plot the 2 final points. These are especially useful when you have a horizontal compression. So let's go through this example here. We're going to sketch one cycle of the function y equals 2 cos x. So first thing I'm going to notice is that I've got a vertical stretch by 2. That means that my amplitude is equal to 2. My domain has not changed. My range, though, goes in between now minus 2 and positive 2. And my minimum value and my maximum value reflect those that are in my range. My period is unchanged. It is 360 degrees. And now I've listed all those, so now I can do some sketching. So first thing I'm going to do is draw on the midline, which is right here at y equals 0. The next thing that I'm going to do is draw on my maximum line at y equals 2. I'm going to draw on my minimum line, y equals minus 2. And I'll label those. So I've got my maximum and my minimum. And then I'm going to sketch a cycle. So I'm doing cos x, so I know that I'm going to start at a maximum. And then my end point is also a maximum at 360 degrees because that is the length of one period. Now I'm going to divide that distance in half and plot my middle point, which is the minimum. Then I'm going to divide first point to third point in half, and then middle point to end point, and then I'm going to connect the dots to get my stretched cos function. Let's look at the next example, which is a horizontal compression. And so here, what you should notice is that I've got a horizontal, not a compression, but a horizontal stretch by 4, which means that my amplitude is still the same. My minimum and my maximum value are still the same, -1 and 1. My domain is the same. My range is the same. But my period is changed. So my period is now 360 divided by k. Remember that k is equal to 1/4. So that means that my period, instead of being 360 degrees, is actually 1,440 degrees. So now that I've stated all my characteristics, now I can do some sketching. Now the first thing I'm going to notice is that this scale is not going to help me very much. So I'm going to modify that. So let's go up by 180 instead. So I've got 180, 360. Let's see, 360 and 180 is going to be 540. And then I've got 720, 900, 1080. This one is going to be 1440. And what's in the middle of that? So 1080 plus 180, 0, 6. There we go. So 1260. So I've just modified my scale there because it wasn't really going to work with my horizontal stretch. Now I'm going to draw on my axis of the curve, which I don't have a vertical shift. So it just stays right at y equals 0. I'm going to draw on my maximum value right at y equals 1. That has not changed. And my minimum value is right here at -1. That has not changed. So the next thing I'm going to do is I'm going to plot my starting point right here at 0, 0. And I'm going to plot my ending point after one period. So 1440, which is right here. Then I'm going to divide that distance in 2. And I'm going to plot my middle point, so right at 720. Then again, I'm going to divide those halves in half, and I'm going to plot my point at my maximum, and then my point at my minimum, still maintaining the shape of my sine graph. And then I'm going to connect the dots so that I get that snake-like symbol. And this is stretched out 4 times than what it would be normally before. Right? Normally my graph would go from 0 to 360. Now it is 4 times as long. Let's do one more example. Here I've got 3 transformations happening. I've got a vertical reflection. I've got a vertical compression by half. And then I've got a horizontal compression by a half. So let's list my characteristics, and then I'm going to plot. So my amplitude is now equal to that A value, which is 1/2. My maximum value is 1/2. My minimum value is -1/2. And my range is going to be in between those minimum and maximum values. My domain is unchanged. And then the last one, my period, has also changed using the equation 360 divided by k. My k value here in this case is 2. So I've got 360 divided by 2. My period is now 180 degrees. So a full revolution of cosine happens in 180 degrees instead of in 360 degrees. So that will fit on our scale here. We could actually draw 2 cycles if we wanted to. So I'm going to start off the same way. I'm going to draw my equation for the midline at y = 0. My equation for the maximum at y = 1/2, and my equation for the minimum at y = -1/2. So my maximum line and my minimum line. Now my starting point normally for cosine is at a maximum, which would be right here. But I notice I also have a vertical reflection, so that means my starting point is now going to be down here at 0 and -1/2. My ending point is the same. It's now going to be a minimum value. So when I divide that distance in 2, I get 90 degrees. Then I divide that distance in half again, and in half again. And now I have my inverted cosine, and it is squished together. If I wanted to do another cycle, I can repeat the same pattern, and then it would go up and down one more time. Those are some examples of horizontal stretches and compression.